All right. Was that good?
Real good.
All right. Right. So what's nice about what we did before is you can get eyes on a line. And so if I give you a line like this, and I say find the slope of that line, the good news is you go into that problem knowing that the answer is already going to be a negative, right? So you have a visual on it. Or if I graph a line and it goes uphill, you can say, oh, I see it. I can see that it's going to be positive. The disadvantage of what we're doing today is that we're not going to have any visual aids. We're just going to have coordinates of points. So today you're not going to see it. I mean, you could make yourself see it if you wanted to sketch the points and just kind of lay out what they look like. That's not an unintelligent thing to do, but it's not generally what people do. So what today's problems are going to look like is we're going to say find the slope of the line containing these points, and they're going to look like this. And when you see it in Delta Math, there's going to be a lot of extra words, so I don't want you to think that it's something different. Let me show you real quick if I still have it up. Let's see. Assignment. So you see how there's a lot of words. So it's not going to be any different than what I'm teaching you. I'm just not going to write all those words every time. So what is the slope of the line that passes through the points, blah, blah, blah. And then it's going to say in simplest form. That just means to make sure that you reduce all your answers. So throughout the lesson, throughout your assignment, if we get something like 6/8, we're going to reduce it to 3/4. If we get 4/1, we're going to write 4, stuff like that. So always make sure that your answers are their best versions of themselves. A lot of times people will miss these, and it's because of this thing that's italicized. I think that's why when they did this, they put it in italics to try to draw your attention to it. Like, don't miss it because you're just forgetting to reduce. That's kind of a silly thing to do. So anyhow, do you guys know how to do this? How to find the slope if all I give you is 2 points without showing you what they look like? Again, there's nothing stopping you from making a sketch and just kind of picturing where they are. But that's not really my goal for this lesson. My goal for this lesson is just to show you how mathematically to find the slope of a line if you never ever get to see the line. So I think once I put this formula up on the board, you'll recognize it from last year. I'm just guessing. So the slope formula that you're most probably commonly going to see in books says slope equals this. And it's pretty hard to get past eighth grade and not have seen that formula once before. It's a pretty common formula, and I think that my coworker across the hall last year probably would have shown this formula to you. And by the way, this formula can go either way. Notice how in the version I have up here, it says second y minus first y over second x minus first x. That's the one I'm always going to use for the record. But you can also switch those numbers around. And if you're if you do backwards of what I show you in the lesson today, you can do first y minus second y, but then you also have to do your x's backwards too. So then you have to do first x minus second x. So just for clarification, I 100% of the time use the purple formula. But understand that the red and the purple will yield the same results. And I'll show you what I mean by that. We'll do a couple of problems both ways so that you can see. And you'll decide today, are you a right to lefter or a left to righter? You'll decide. All right. So let's use the formula and let's take a look at those numbers over there. Who do you suppose that guy is? He's the first X, so we call him X1, right? Those little numbers aren't anything fancy. They're just labels. They're called subscripts, but they're just labels. Who do you suppose this guy is? He's the first Y, so he's Y1. And it's important that we call them X1 and Y1 so that if we're kind of If we get a little nervous with math, then we know exactly what numbers to plug where into the formula. Who's this little fella here, the 6?
X2.
He's x2. He's the second x. And then this 4 over here is y2. Okay, give me just a second. So having said that, I mean, this is this will go down when I retire from teaching as something I can't teach. I can explain it, but for some reason, it's just one of those things that I don't know if someone wrote a book about this ever that was like, this is how you actually teach kids to do slope. But what you're going to see is it's one of the easiest things we've done all year. It is one of the easiest things we will do all year. And it is one of the things that we will miss the most this year, which is crazy. It's like those don't add up, but there's something about it. I think we get lulled into a sense of, oh, this is beneath me. So I just need you to be vigilant about this. Yes, it's easy, but it's very, very missable. So having said that, slope is a fraction. And what we're going to do first is we're going to do what the top of the purple fraction says. And it says to take the second y minus the first y. And I'm going to illustrate that with an arrow. It looks like this. You're going to see a lot of these arrows in the next few minutes. So I'm going to go second y minus first y. And I'm going to write that down. I don't want the answer. I don't want you to say something about what it actually equals. I'm just going to model it. I'm going to say, well, here is the second y minus, and here is the first y. And we'll worry about what the answer is later. And then it's a fraction, so I'm going to put over. And then I'm going to model the bottom of the fraction, which says to do the second x minus the first x. So it's going to be another arrow that runs alongside its buddy. And again, I'm not worried about what the answer is. I'm just worried about writing it down. So it's going to say 6 minus 4. So that's what slope looks like, is we're just finding the difference in the y values and dividing it by the difference in the x values. The key is you have to go the same order. Like notice both of my arrows go from east to west. That's what the red formula is for, is to show you that you could be a west to east person, provided that you're consistent with it. It can't be back and forth kind of thing. Like your arrows can't crisscross. So what is 4 minus 5 on the top? -1. And on the bottom, what is 6 minus 4? 2. So the best answer in the world that you could give for the slope would be to say that the slope is -1/2. Note that the negative is not on the 1, the negative is not on the 2, it's just a negative slope. That means this line would go downhill. Okay? And again, you sit through that and you think, how could anyone ever miss this? Like, I should be able to give you 100 of these in a row, and you should never miss one of them. It's just not the way it works. It's a very odd sort of thing. Yeah, bless you, Abby.
Thank you.
Um, Here's our next one. What's my first subtraction problem going to be? I don't want the answers. I want to know what's it going to say. It's going to say 5 minus 1. Perfect. And this is usually where the trouble starts. If you've already now closed your eyes and started to nod off and think this is a great time for a nap, don't, because this, I think, is where the trouble begins. If I do this problem, what does it say? Doesn't say 3 minus 3. It does say 3 minus, but the number at the tail end of the arrow is -3. And that, I think, is probably a huge part of the problem, is that we don't give ourselves sometimes a chance to see that, right? So now we need to answer the math questions. What is 5 minus 1? And what is 3 minus -3? It is 6. Somewhere along the line in the last few years of your life, someone taught you that when you subtract a negative number, a minus a negative number, that doesn't actually exist. Subtracting a negative is really the same as just adding a positive. So that, I think, is when slope reaches out and kind of claws at kids. We forget sometimes that if the target number is a negative, we got to switch it to plus. And 3 plus 3 is 6. So what would we say is the correct slope answer for this? 2/3. Perfect. Okay. Let's go again. By the way, while I'm here, I don't want to keep doing this, but let's do one of them backwards. And I guess I'll do this just once, just so you can see what it looks like. So I assume you're going to be okay doing your arrows the way I did, but some people just like to do things their own way. They like to chart their own course. So if I do both my arrows backwards, my top isn't going to say y2 minus y1. It's going to say y1 minus y2. What would that subtraction problem say? Say 1 minus 5. Okay. And the only reason I'm doing this with you is to make sure you buy into the fact that it works both ways. Again, it just won't work if you crisscross. Your arrows can't cross midair. They got to be parallel, kind of like go the same way. And then if I do this one, what does that say? -3 minus regular 3. This is not a situation in which a minus and a negative make a plus because they're not touching butts. They're separated. Okay, so this is just old school third grade addition. On the top, what is 1 minus 5? -4. And on the bottom, what is -3 minus 3? -6. And a negative reduced with another negative is a positive. And you can see that the answer is still 2/3. That might be the last time that you ever see me do one left to right. It's just not what I do, but I wanted you to understand that you can go either way. If you're more comfortable in that direction, then you get down with your life. Bless you. All right, let's go again. 4, -2, and the other point is -2, 4. So first here, what's that say? 4 minus -2. I like to, when I'm speaking on this first day of slope like this, I like to pause after I say the word minus just to make sure we have a chance to kind of digest. Minus is built in, but sometimes what comes after a minus is a negative, right? Okay, and then I'm going to go over, and then I'm going to do my green arrow. And just again, I don't need an answer. Just what would that subtraction problem say? Yep, -2 minus regular 4. And then we math. On the top, what do we get? We do, because our minus and our negative are touching butts, and when they do, remember, they become something. It's not called a positive sign. Contrary to popular belief, it's called a plus sign. It's a verb. Nothing changes on the bottom. What do we get on top? 6. What do we get on bottom? -6. When you do fractions, if one of them is a positive and one of them is a negative, overall, your answer is going to be a negative. And what is 6 reduced with 6? So our slope is a perfect -1. If you could see this line, it would go downhill, probably looking something about like that. Okay, and it would have a perfect downhill slope of down 1, right 1. That's usually what those look like. Next one. 7, 3, and 7, 5. What's our top going to look like? Perfect. Write that down. So our top is modeled as 5 minus 3. Our bottom is modeled as what? You'll want to give this one a special place in your notes because something weird's going to happen. The top, we get what? 2. Bottom, we get what? Any ideas as to what this means? There is no slope. This is a vertical line. When a line has a rise of 2 and a run of 0, That means it never goes sideways. It's vertical. So in a case like this, we say the slope is undefined. Unless you're one of those people that doesn't like that word, then you would write no slope. And remember, on these ones, we don't write m equals. We just pick one of the descriptions. Okay. What a great thing to have in your notes. So reminder to self, when zero's on the bottom, I get an undefined slope. Okay. Let's go again, round 5. There are 3 more, by the way, just for your mental preparation. What is my top going to look like? Perfect. 10 minus -5. What's my bottom going to look like? 19 minus -1. Okay. And I see 2 pairs of touchy minus negative-y things that become pluses. So the top is actually saying 10 plus 5, which is what? 15. And the bottom is actually saying 19 plus 1, which is 20. What's our final slope on this one? No. 3/4. Divide them both by 5 and you're good to go. 2 more. What's our top say? Good. Over. And what's our bottom say? 3 minus -2. And there it is again, that oddity of the minus and the negative button up against each other, which becomes a plus. What do we get on top? Bottom? What do you think this one is? Yeah. Yes, this is a horizontal line. So the slope actually equals a number 0. 0/5 is not simplified, okay? It's not in simplest form. 0 is simplest form. So that would be a horizontal line. That means that the line goes 0 up or down, no rise, but lots of run. That's what a horizontal line could be described as. This last one, I don't have any more real holes to fill when I was writing this lesson. I just wanted to do one more that had a 0 in it so that you wouldn't think that it was anything odd. So this last example, I'm not trying to accomplish any end game. That problem, the end game was obviously showing you horizontal. The one a couple before that was trying to show you vertical and defined. This one is just to alleviate potential future questions. So that's all. We have -8, 4, and another point, 4, 0. Again, I just wanted to make sure you got eyes on a problem and that you didn't think that the 0 meant anything. It's just a number. It's not going to change the outcome of this problem. So when I model this out, what does my top say? 0 minus 4. And then when I model the bottom, it says 4 minus -8. And really, I mean, this is predicated on the assumption that you never mess up addition and subtraction. You're never the kid who says 0 minus 4 is 4, something crazy like that, right? Because I mean, everything's harder if you're that kid. So let's assume that our skills are good. What's 0 minus 4? 0 minus 4. -4. If you start at 0 on the number line and go left 4, you are at -4. And on the bottom, what is 4 plus 8? So overall, is the slope positive or is it negative? So we just write negative. Remember, the negative doesn't go on the top and it doesn't go on the bottom. And what does 4/12 reduce to? 1/3. If I wanted it to be -3, I would have written you a problem that came out with the 12 on the top and the 4 on the bottom. Then it would reduce to -3, right? You're all good. Any questions about that? This assignment is on Delta Math. Delta doesn't do everything perfect, but it does a good job with this. This is just rapid drill and practice with finding slope when you're not given a line. So have at it. That's what you're doing for the next 20 minutes. I'll keep the recording alive. If you get one and you're like, I don't know what I'm doing wrong or I need some help, just let me know. And I'll add it to the tail end of the recording here. Will you read me your points?
Five, seven.
So I think when I teach this lesson again, 6th hour, I'll add an example like this. Um, when you do the top is not what this question was about. It's obviously just 4 minus 7. But the bottom is a little bit different. It's got a lot of negatives in it. So let's just have faith here. It's first number minus second number, right? So what catches our eye in this problem is not this negative over here. He's just where we start on the number line. What catches our eye is these two are touching butts, right? So they're going to become a plus sign, and then the problem is ready to be done. So what is 4 minus 7? And then what's -2 plus 5? And -3 over 3. There you go. So the only negatives that we worry about are the ones that are right after minus signs. Anything else is just like normal. Okay.
If you get an undefined answer, do you just like write undefined?
Now there should be a button that says undefined. You can just click it.
I didn't see that. Sorry.
You're good. What are your points? Yep.
6. You were in
6, 10,
nope 7.
6, 7. Hey, Rowdy, what do you think of that, buddy?
And then the second one, 16.
So what is that? It's this. 22 minus 7. Don't worry about answering them as you go, okay? While we're practicing and we're new at this, we're just going to keep writing down what the math problems are. It's good practice, okay? And then what's this going to be?
Oh.
So 16 minus 6. So this is what, if I were to walk back there right now, this is what I should see on your paper. Is this exactly this? Perfect. And now we need to do the math. On the top, what is 22 minus 7?
50.
I agree. And on the bottom, what's 16 minus 6? And you have to reduce, right? You get that. What can these numbers both be divided by? 5, which is going to result in what? Done. Okay. Every time, subtract, subtract, reduce. Just over and over again. Yeah, Rowdy?
1 -9.
Did you say 1 -9?
Yeah. And 4 -7.
Okay, so as soon as you get out some scratch paper, I'm going to pause this while you do, then I'll give you a hand, okay? Thanks. Does anyone else have a question while I wait for him to get some paper? Yeah. 18 and -3. Okay. So what's this going to say? -3 minus, pause, and then say the second number, -3. Give yourself that pause so you don't overlook any minus negative combos, okay? And then what's this going to say? Okay, great. Now what we're going to do is we're going to go through and we're going to look for any minus negative combos that we need to switch. I see one, you see it. It's right here. We're going to change that to say plus. Good. Understand that the minus and the negative do not survive. They both destroy themselves in the act of creating that big, beautiful plus sign. Okay. So on top, what's -3 plus 3? And on the bottom, it's 15. So what is our answer? No, 0. 0/15 is not reduced. It's not simplified. Simplest form of a fraction means to make it the best, cleanest, most concise, short version of itself that it can be. 0/15 is equal to something else. 0, right? Got it? Okay. Think homeboy might be ready and then he'll be next in the queue. Okay. So what's our top going to say, Rowdy?
-7 minus -1.
Perfect. Couldn't have said it better myself. And then what's our bottom going to say?
4 minus
Perfect. So do you see anything that concerns you here?
the negative.
Be more specific. This negative right that I'm pointing at is not a concern. Okay, let's be very clear. This that I'm pointing at with a red arrow is called a minus. This one is called a negative. And when a minus is immediately followed by a negative, we should be concerned. So we're going to get rid of those. And in their stead, we're going to put a plus sign. The negative in front, he's got no part of this. He's just the starting point of the problem. Are you okay?
Big. Bill.
Well, yeah, I mean, I just want to know, are you okay on why I put a
Yeah,
plus there?
yeah.
You sure?
Yeah.
Then the answer is 2 over, what's 4 minus 1? Can you reduce that? There's your answer.
Thank you.
Showing work is going to help you a lot. What's up, Coop?
I'm already on the next one.
Oh, so you're good?
Yeah.
Some help? Natalia? What's up?
Okay, so if the 0 to top.
Negative. Okay.
Negative what?
-9 and another. And -9 and -7.
What's that going to say?
-9 plus. Sorry, -7 plus negative.
No. So you're just,
Right.
so this is why slope is hard. And it's been this way for 30 years. But to get you to do this exactly the way I do it is the goal here. So you're going to take the first number, -7, and you are always going to put a minus sign, not a plus, a minus. Slope is a difference in y and a difference in x. Now, what's going to go after that minus sign?
-9.
Correct. And now let's move to the bottom. The bottom is going to say what?
Negative.
Good. I need to know you're going to get through that first step 100% of the time. Got it? More work, less chat, please. I don't want to have to do another seating chart. Please, let's just work where we're at. Thank you. So you should see 2 instances here of issues. I see a minus and a negative right here that I'm going to get rid of. I'm not going to leave them there as evidence. I'm putting them out of their misery, and in their stead, I am putting a plus sign. But then I see it again that on the bottom, there's another minus and a negative that are up against each other. Bless you. So I'm going to scribble them out, and in their stead, I'm going to put a plus. Mark my words, there will come a point where you're not going to do this much work. You're going to see things and you're going to just know them quicker. It's just not today. We're going to be nice and patient and slow. Now we're ready to do math. We haven't actually done any math yet, literally none. But now we have to do some basic math. What's -7 plus 9?
Okay, I see what I did.
But you did never answer my question. 2 is correct. And then on the bottom, what's -9 plus 9?
There.
And what is our slope?
Just 2, right?
Go back into the notes you just took and look at the 4th example.
stand up if you're already one. Undefined, right?
So you need to remember that when zero's on the bottom, that the slope is undefined. And there's a button for that. You just click the little undefined button. If you're sitting there right now without a whiteboard or paper and pencil in front of you, I'm very disappointed in that choice. I don't know if I was direct in saying that you had to do your work on paper, but to try not to is silly. So I'm not going to embarrass anyone or shame anyone. I just would tell you that you should make good choices. Yeah, Rowdy.
What's -4 plus 4? 0?
I hope so, or I've been doing it wrong for a long time.
Does that mean it's undefined?
I don't know. You're not giving me enough information.
Well, -9 over 0.
That's there's a difference between these two things. I want to be perfectly clear, right?
Oh, 0 is on the bottom.
If I know. So I'm saying if you have this, then it's undefined. If you have this, then it equals 0. The location of the 0 determines, do we have no rise or do we have no run? 0 on the bottom is undefined, 0 on the top is 0.
Well, I got -9 over 0. I put undefined, but I got wrong.
So would you read me your points?
-4, -10, and -7, -9.
What's that say?
-19 plus 10.
What's that say?
I don't know why I put down another 4. That's -7 plus 4.
And now we math, and I agree with what you said about the -9 on top, but now we see the error in our ways. You already spotted it. -7 plus 4 is what?
It's -3.
So what's our slope?
-3. 3.
Are you guessing?
3 goes into 9 3 times.
I agree. I just want to make sure that you're completely married to the idea that it has to be +3. Not a guessing game, right? A negative on top and a negative on bottom cancel out. So it goes to positive.
Okay, thank you.
You're welcome. More questions? What you got?
So. Wait, so the 6.
So your points are like
6.0 and
so 6, 0.
yeah, 6.0.
So like the x coordinate is 6 and the y coordinate is 0, right?
Yeah. And 21 and -12.
Did I get that right?
Yeah.
Okay. So what is this going to say on our paper?
20 minus 0.
Correct. And then what's this going to say on our paper?
20 minus.
Nice. So all we've done so far is just follow directions, right? We made a couple of arrows. We modeled some, we haven't actually mathed anything yet. And there's no minus and negatives that are going to change. So this is just do what you see. What is on top? What is -20 minus 0? And on bottom, what's 21 minus 6? Okay. So when I look at this, I think to myself, first off, I know one thing. I know the answer is going to be negative because one of them's a negative and not the other, right? And what can you divide 20 and 15 both by?
5.
So divide them both by 5. What's 20 divided by 5? What's 15 divided by 5?
No, don't.
Okay, this, I didn't simplify the first time, and so I got it wrong, it's been day out.
Simplify, simplify, simplify.
Yeah.
Always simplify.